Welcome to my attempt to solve the LinkedStack practice quiz. And so here's the quiz. Write the following method for the LinkedStack class. The LinkedStack has a private link node called top of the stack, and we have to implement the push method on the stack. So let's get started. Linked implementation of the stack. A stack. Author Cam Moore. Okay, public class linked stack generic implements stack 211 generic. And so now we have our private linked node E, top of stack. You'll remember the link node from the linked list class. It has a data element that holds the actual data and a pointer to the next node. So the top of the stack will always point to the top of the stack, and then there'll be a linked list, singly linked list that is the rest of the stack. So we now have our method pushes the item onto the stack. It has one parameter, item to push. It returns the item pushed on the stack. And since we're doing a linked implementation, there's no chance of us failing that, so it's going to always return the item, very simply. So public E push E item. So we want to create, the first thing we want to do is create the link node to hold the item. So node equals new node E. And I'll use the default constructor. I could put, if their constructor is there to add the item, I could do it, but I can just say node.item equals data. Now, what do I want the next pointer to point to? The top of the stack, if I want this new node to be on top of the stack, so I could say node.next equals top of stack. Right, so now this new node points to what was the top of the stack. So now, what do I need to change where the top of the stack points. So what should that be? So I want to say top of stack equals node. So now we've just inserted this new node into the top of the stack, and its next pointer pointed to whatever the stack held in it. If it was empty, then we have one node in our stack. If it had 1,000 items, it's now got 1,001, and this new node, the top, points to the rest of the stack. So that is, we're done. Well, we successfully inserted this new top into the top, and we made the top of the stack point to it, so we now know where the top is. Now we need to return the E, and so now we satisfy the interface or the method signature by returning the item, because we successfully inserted the item into our stack using a linked data structure. So now we need to talk about the big O. Hence of push is, well, there are no loops, so we just have straight line through, so that is big O of 1. It's basically takes how long it takes to move some pointers around. So it's not dependent on the length of the number of items in the stack, So it's big O of 1. And again, we are creating a new node. We stick the data into that node. Great. It was a typo. Node.data, that's the thing that's called, is equal to item. So no one is perfect, certainly not me, right? So we want to fill this node's data with the item. We then figure out where this node's next pointer needs to point to, and it should point to the top, the old top of the stack. And then now we move the top of the stack to point to the node we just created, which is the new top. And we need to return the item. We could return item, or we could return node.data, which are the same thing. Either one. And again, the performance of this is big O of 1. There's no looping. It's all sort of summing up of constant time. It's not dependent on the size of the stack. We're inserting at the beginning. So that's my implementation of the push method for a linked stack. Thank you for your attention.